if I keep them as smaller length. Okay, so this is what we got with 4 subintervals. We got a left 4, we got 1.75, we got a right 4, we got 3.75, and a with a mid 4. I'm copying them from the other page. Okay, perfect. Now what I would like to do is increase n to 16, maybe 32, maybe 64, maybe 128. What am I trying to tell you here? Why? Because I'm not happy with 4. I think I can do better if I have 8 or 16 or 32. I can get a better approximation if I have more subintervals. I will have less error, and I will be able to fill in this area and determine it exactly. What am I trying to say to you here? What concept is this from what we studied so far in this class?
The more subintervals you have, the better chance.
Yes, and what is that operator that we've been using exactly? What is the operator that we've been using when we get closer and closer to something? Say it again.
Limit to infinity.
Thank you very much. So we really want infinity. We don't want 16, 30. No. I want n to approach infinity so that I know that nothing is missing. Okay, from what? From the sum of areas of all subintervals. Sum of areas, base times height. This will be exact. There is another operator before I come back to this operator called summation notation. So what is all that? So for example, if we want to add 1 to 2 to 3 to ... to n, okay, we don't want to write this. We're going to use a Greek letter. It's S, but it's a Greek letter S, okay, from what it's called an index, starting with the index I equals 1 through the last one from I. So do I need this complicated notation? At least I need to understand what it means. So if I have the sum from I equals 1 through n, so this is called index, and this is the lower index, lower limit. The index is I. We normally use I, J, K for index. You can use A, you can use anything, it doesn't really matter. So the index is I in my example. 1 is the lower limit, n is the upper limit. It has nothing to do with this word. When I use the word limit here, I'm not talking about the operator limit. I'm just saying the last one, upper limit. So the sum means this operation. So when I is 1, I have 1. Then the sum says plus. When I is 2, I have 2, and so on and so forth, and I end with 9. So for example, now if I want to expand, let's say 2k plus 1 from k equals 3 to 4, just 2 elements, 2 entries, 2 values for the index. I can choose anything. I just didn't want to write too many. We can use 14. Doesn't matter. So I start with k equals 3. So I have 2 times 3 plus 1 plus, when k is 4, 2 times 4 plus 1 plus, when k is 5, 2 times 5 plus 1. I write 3 dots and plus again. Can anyone give us the last one of this sum?
Plus G.
That's it. That's it. So this is how this summation operator works. Why do I need all this? For this. To replace it with a sum. Okay, so now we know what the summation notation is. So how are we going to write this? So the exact area is the limit as n approaches infinity from the sum of base times height. The base is denoted by delta x, and we had this in the previous chapter, times the height. How did we get that? How did we get these heights? How did I get this and any height? Either this or this or this. How did I get these heights? F of x. And this is xi because it's from the first subinterval to the last one, from I equals 1 through the last subinterval. This is called limit of the Riemann sum. And this is the exact area. I'd like to look at a couple of examples. On page 388, and then we're going to find some areas. I'll let you choose, of course, if you want. Let's say 14, just to see how the summation notation works. 14, of course, on page 388. So we have the sum from I equals 0 to 5 from -2 to the I power. They're asking us to express it without summation notation. Fine, so let's express it without summation notation. When I equals 0, -2 raised to 0, plus. When I is 1, can anyone give us the next term? Don't calculate anything, we just want to see them first. The next term. -2 raised to power 1 plus the next term. -2 raised to power
2.
Very good. Plus -2 raised to power
3.
Very good. Plus -2 to raise to power
4.
Good. And what is the last one?
5.
That's it. And you can calculate if you want. We can plug that in the calculator and can determine it. We're not asked to determine it, we're only asked to, but we can determine it. That's not a problem. You want me to do that? So this is 1, -2 to 0 is 1. This is -2. This is -2 to the second power, which is 4. This is -8. This is 16, and this is -32. So let's see what we have here. So this is -16, and this is -10, so plus 5, -11. So 32 minus 16 is -16, -8, so that's -10, and -10, -10 plus 5 is -5, so this is -21. Okay. Is clear the idea of the summation, how we use the summation notation? Yes?
Yes.
Okay. So now I would like to determine any cost function or any, let's say like 20. So see how we are 20 on 389. I'm going to copy the picture. So we have this figure. They're giving us a marginal cost function. It looks something like this. And they have 100, 200, 300, 400. Okay. And it says total cost function from marginal cost. So first, let me just say this. Why are we calculating these areas? Why? If C of x, the function C of x, so this is given, let me write it, 0.0003 x squared minus 0.2 x plus 50. So at this point, when we're asked to determine C of x from C prime, C of x from C prime will simply be, and we're going to determine that, but we cannot do it at this moment. So in order to determine, we're asked has found that its marginal cost in dollars from the X jackets, whatever, and it's in dollars for the X jacket produced is given by. So we have the marginal cost. Question: approximate the total cost of producing 400 jackets by computing the sum. So they're asking us to find, let me copy the sum from I equals 1 to 4 from C prime of x I delta x. Again, they're writing like this. It's normally base times height. It's fine, but it's normally base times height, not height times base. Just to make a comment, so delta x equals 100. Okay. So obviously they're already giving us the picture. So we're asked to determine the sum. Well, this is nothing else but the area. It's not exact. It's an approximation. Why? What is missing here for the exact? The limit is missing. Since there is no limit here to make these subintervals to go to infinity, obviously this result will be an approximation. They're not telling us if to use the leftmost point, rightmost point, or midpoint. You choose. Sometimes they specify, sometimes they don't specify. So what would you like to use? Would you like to use the leftmost point, the rightmost point, or the midpoint? We only have to make a decision. So if we want to use the leftmost point, we'll start with these. If we want to use the rightmost point, then we're going to use this. And if we want to use the midpoint, then we're going to have to use this. Height at those points. Any preference? Anyone?
We just do the midpoint?
Midpoint it is. So if that's the case, if we want to use the midpoint, so this was 0 and this is 100, 200, 300, and 400. If we want to use the midpoint, we have to determine the coordinate of the midpoint. So here, the x-coordinate of the midpoint. So this is obviously 50. This is obviously 150. This is 250. And this is 350. So then, the area will be approximately delta x. Delta x is the same, always the same. So it's 100. So now I will determine the function value, the C prime value at 50, C prime at 50, plus C prime at 150, plus C prime at 250, plus C prime at 350. Put that in the calculator. in y equals, I'm going to enter that function, 0.0003x squared minus 0.2x and plus 50, and calculate those numbers. So at 50, at 150, at 250, and at 350. Okay, here's what I got. 100, so I don't forget it. So 40.75 plus 26.75 plus 18.75 plus 16.75. So 100 in parentheses, 40.75 plus 26.75 plus 18.75 plus 16.75, and I got 10,300. Any questions? Will I get the same answer if I use the leftmost point or the rightmost point? No.
No?
No, of course not, because f of 0 will not equal f of 50. It will not equal f of 100. So the numbers will be different. So if it's specified, it should be specified in MyLab Math, which to use leftmost point, rightmost point, or midpoint. If it isn't, then they may consider the answer incorrectly. So they should